Hello everybody. Okay, so in this video we're going to go over the different classifications of pressure relief devices. And so before we begin the classification, let's get a formal definition on what a pressure relief device is. So a pressure relief device is a safety device that responds to the static pressure at the inlet of the device, which basically is the pressure inside the vessel, and it activates to open when the pressure of the vessel exceeds a predetermined limit, which is the set pressure of the pressure relief device. And essentially, it helps protect the equipment by preventing excessive internal pressure buildup under abnormal or emergency conditions, because usually vessels aren't designed to run at overpressure incidents, or pressure relief devices are only installed to protect against abnormal cases when these overpressure situations occur. And also some designs also safeguard against vacuum formation. So if you look at this slide, these two pictures are incidents of underpressure. So if vacuum is forming inside the vessel, you also have pressure relief devices that can help release and mitigate these underpressure scenarios. So in other words, pressure relief devices, it's just a device that relieves overpressure and can also provide relief for underpressure in a system to prevent exceeding the system design pressure range. And so the way I've classified the pressure relief devices is reclosing pressure relief devices, and in that case, it's pressure relief valves, or you could have non-reclosing pressure relief devices, and in that case you can have like a rupture disc, which is a disc that you have to replace, or pin devices, which pins that you'd have to replace after the device activates. So if you look at non-reclosing pressure relief devices, they're a type of pressure relief device that essentially stays open after the set pressure inside the pressure relief device and the vessel is reached. And it doesn't automatically reset or reseat, but may include a manual mechanism for reactivation. Similarly, or on the other hand, pressure relief valves, they're a type of pressure relief device that allows excess pressure to escape, and once conditions return back to normal, so once the pressure inside the vessel goes back to normal, the valve would have automatically closed to prevent further fluid discharge. So you might be wondering when to use a reclosing versus a non-reclosing pressure relief device, and that's usually a decision made by the design team. Here are some advantages and disadvantages of each. So for a reclosing pressure relief device, if we're talking about pressure relief valves, the advantages are it automatically reseats after the pressure drops below the reseating pressure, and it allows the system to continue operating, and that is a huge point to remember. The system can still continue operating even after the overpressure incident. And it's good for recurring overpressure scenarios and normal process pressure variations. So if you have feeds that are feeding the vessel and you know that there can be process pressure variations or frequent upset scenarios in the pressure of the feeds that would result in a vessel having overpressure scenarios, then you might consider a pressure relief valve because it can handle multiple overpressure events without the need to replace the valve. And when we say replacement, we don't necessarily mean replacing the whole valve. Usually there's a replacement kit, and that can mean just replacing the seals if there's any wear and tear on them, or even the manufacturer can fix the spring or reinstall a new spring, but you don't have to discard the whole valve. And so in terms of a long term, you'd have long-term lower maintenance costs since they don't need, the valve doesn't need to be replaced after each activation. The disadvantages of a pressure relief valve is that it's usually has a higher initial cost than a burst disc, which is a non-reclosing pressure relief device. It has more moving parts, and so it can potentially fail. The likelihood of it failing is higher because it has more moving parts than a burst disc. As we look into pressure relief valves in details, we look at all the different components that are inside. Pressure relief valves require periodic testing because, as I've mentioned before, you could have wear and tear on the seats, or you could have the spring as well. Maybe corrosion or leaks inside the spring could cause the spring to shift any of its set pressure. And pressure relief valves could also leak due to the wear in the seat. And pressure relief valves are not suitable for process fluids that have solids. Or for any sticky or solidifying media that could prevent the seat from properly reseating after it activates. Now, on the other hand, for burst discs, the advantages are it's simpler with no moving parts. It's just a disc. It's more reliable because it's simpler. It has lower initial costs. It's better suited for highly corrosive surfaces. In this point, it's because the burst disc is just a disc, and so you'd find different materials of constructions. And that's not to say that pressure relief valves out there right now don't have different materials of constructions, but you might find them very expensive. And because of all of the different components in them, you have to make sure that all of these different components are suitable with your process fluid as well. Back to burst discs. Burst discs, they're good for rapid depressurization needs. So one source here reports that the burst disc could depressurize the whole vessel in less than 4 milliseconds. Now, the disadvantages of burst discs is that after each activation, you have to replace them. And yes, we did say that they're cheaper than pressure relief valves, but they're not free. So at some point, depending on how much you have to replace them, you might exceed the price of a pressure relief valve. And in order for you to replace them, or once the burst disc is activated, the whole system must shut down for you to replace them. So you can't continue operations as pressure relief valves. They also have higher long-term costs, and that's because if frequent activation occurs, as I just mentioned. And with burst discs, it's either all or nothing. There's no partial relief. So it's either it bursts or it doesn't. More sensitive to temperature fluctuations than pressure relief valves. So you'll find documented cases online where you had design engineers improperly sizing burst discs because you have the vessel operating at a high temperature, but where the burst disc is installed is above the vessel, and the pipe leading to the burst disc, or pipe leading to the inlet of the burst disc, wasn't insulated, and so the burst disc is at a lower temperature than what it was initially sized for, and therefore it did not activate at the right set pressure, and you had the vessel exploding. So this is something to keep in mind. And also another disadvantage is that it's sensitive to uneven torque on the flange. Usually these discs are sandwiched between two flanges, and the manufacturer would give you the right torque settings for these bolts that you need to have. And if you're not careful with that, uneven torques on the flange bolts can cause them to shift in the burst pressures. And unfortunately, you can't check the burst pressure on the field because once it bursts, you have to use another one. Another question that I get is, can people use them in series, or can they both use together? And the answer is yes, and we will discuss that in the next slide.